So let's move to the next topic. Actually, almost we have already discussed all these factors in the previous classes. So here I have just gathered all the information to compare between the physical absorption and the chemical absorption. So actually this is, today we will finish all the theoretical background and then we will move to the different theories and we will further study how to study the physical absorption and the chemical absorption along with their application. So the first parameter is the absorption forces, and the differences are written over here. So we have already discussed due to the absorption forces, you can also differentiate between the physical and the chemical absorption. And because in the physical absorption, there are the weak forces, and weak forces are the van der Waals forces. There may be the dipole forces, ion dipole forces, or the hydrogen bonding. All these are the weak forces. And for the chemical absorption, there must be a strong bond, and these bond should be a chemical bond. That means it may be a ionic bond, covalent bond, or the coordinate covalent bond. So based on the absorption forces, you can differentiate between the physical and the chemical absorption. And the second one is also temperature. So temperature, physical absorption is appropriate at temperature below boiling point of the adsorbate, because no activation energy is required in case of the physical absorption. So why it is written over here, it should be below the boiling point, because when you provide more temperature, maybe the adsorbate is going to boil, and then there should not be any absorption process will be happen between the adsorbate and the adsorbent. So that's why it should be, if you want a physical absorption, the temperature is very important. It must be below the boiling point of the adsorbate. That means it is the solute which you are going to adsorb on the surface of the solid, and solid is the adsorbent. Clear? Now, what about the chemical absorption? It is actually opposite to the physical absorption. It favors at high temperature because it needs the activation energy. Whether it is the exo or the endothermic reaction, at the start, each of the reaction should need the activation energy to cross that barrier. And that's why you need the temperature to start the chemical absorption. So for the chemical absorption, you need high temperature, and the physical absorption usually it operates at the low temperature. Again, the third one is the reversibility. This we have also discussed before. Physical absorption are the reversible process or recoverable process, because it is going to follow the Le Chatelier's principle. When you adsorb, and at certain condition, if you increase the temperature or the other parameter of the pressure, then it may be going to be reverse order, and that the term is called the desorption. Okay. So adsorption and desorption happens with the physical absorption. That's why the process should be a reversible process. That means it is going to do both of the direction, forward and the backward direction. But for the chemical absorption, it is the irreversible process. And similarly, you can define this with respect to the absorption forces, because there are a strong bond between the adsorbate and the adsorbent, and you cannot reverse that process. And the example, one of the example is written over here, that is the reaction between carbon and oxygen, and this will form the carbon dioxide. Actually, it is the adsorption of the carbon dioxide on the surface of the activated charcoal, that is the carbon. And after the adsorption, if it is formed the strong bond between the carbon and the oxygen, of course, it will be CO2, and that is the carbon dioxide. And if it is physical absorption, only oxygen is just absorbed on the pores of the activated carbon, and with a certain condition, the same oxygen is removing back. That is called the desorption. So the physical process is the reversible process, while chemical adsorption is the irreversible process. Clear? If you have any question over this. The fourth one is the number of layers adsorbed, and this is related to the reversibility of the reaction. The physical adsorption is multi-layer adsorption. What is multi-layer adsorption? That means if the first layer is when all pores are empty and the adsorbate is going to be adsorbed on the surface of the adsorbent, and the pores are all, let's go, all pores are the occupied, and this is the first layer. And then this layer of the adsorbate is going to provide the opportunity to adsorb another molecules of the adsorbate, because there are the weak forces are involved. तो ये फील्ड फोर्सेस तो कहीं भी एग्जिस्ट कर सकती है, एडसॉर्बेट मॉलिक्यूल के बीच में एग्जिस्ट कर सकती है. लेट्स गो वाटर, देयर आर द हाइड्रोजन बॉन्ड्स एंड देयर आर मेनी अदर. सोडियम क्लोराइड, if you dissolve in water, sodium is going to interact with the water molecule. This is called the ion dipole forces, because the water is having the dipole and the sodium is the ion, and this is the interaction is called the ion dipole forces. So similarly, if the molecules are adsorbed on the surface, and then the first layer is acting as another adsorbent to further adsorb the gas or the liquid, that means these are the adsorbate. So the process will happen again and again. That's why this is called the multi-layer adsorption process. But in case of the chemical adsorption, because there is a strong bond between the adsorbate and the adsorbent, and there is no further opportunity for the chemical bonds. अगर एक दफा bond बन गया हुआ तो वो एक ही bond रहेगा. If there is no adsorbate and no adsorbent, then there is no possibility for the further formation of the chemical bonds. That's why the chemical adsorption is the monolayer adsorption, and the physical adsorption is the multi-layer adsorption. So based on the adsorption forces and reversibility, you can define the fourth one, the number of layers adsorbed. And with respect to the multi-layer, if the process is multi-layer, and then the second is the large amount is adsorbed. Of course, when there is a multi-layer adsorption, one layer, second layer adsorbed, more amount of the adsorbate is adsorbed. If there are 3 layers, then again more amount of adsorbate is adsorbed. So that's why in case of the physical adsorption, you will get more amount of adsorption of the adsorbate as compared to the chemical adsorption. Clear? So both the amount is related to the number of layers adsorbed on the surface. More will be the layers, more will be the amount of the adsorbate adsorbed on the surface of the adsorbent. Clear? Now next, fifth, sixth, seventh. The fifth one is the activation energy. And for the physical adsorption, because these are the weak forces, no activation energy is involved. While in case of the chemical adsorption, you must need the activation energy to climb that barrier, the activation state, or to break the bond between the adsorbate, and should be a formation of the new bond between the adsorbate and the adsorbent. So activation energy is involved, but in case of the physical adsorption, there is no activation energy, or activation energy is negligible. You can say activation energy is near to zero. Maybe in some of the cases you have the activation energy, but here we are going to compare between the physical and the chemical adsorption. So of course, as compared to the chemical adsorption, the activation energy in case of the physical adsorption is zero or near to zero or negligible. The sixth one is the enthalpy or the heat of adsorption, and this we have already defined in the previous class. What is the heat of adsorption? It is the energy liberated when 1 gram mole of any of the adsorbate is adsorbed on the adsorbent. So that means this is called the heat of the adsorption, and this is similar to the change in enthalpy or the other change in energy with the terms we are using, because here the adsorption process is happening. That's why we are just, the heat is related to the adsorption, that is called the heat of the adsorption, and this is going to be liberated. And the comparison is written over here because in case of the physical adsorption, generally, this is not the exact, you cannot fit all the type of the processes by using these values, but here these are written just to compare which one is having more heat of adsorption as compared to the other one. So for the reference physical adsorption, the heat liberated or the heat of adsorption or the enthalpy of the adsorption is less than as compared to the chemical adsorption. And what is the reason why this is going to happen? Due to the weak forces, because heat of adsorption, energy is released. So when energy is released, when there is the bond formation. So after because in the physical adsorption, there are weak forces, not too much energy is involved. So heat release is less as compared to the chemical adsorption. तो जब भी chemical bond आपके पास बनेंगे, आपको पता ionic bond है या covalent है, then coordinate covalent, there is a strong bond and more energy is released. That's why the chemical adsorption is liberating more heat of adsorption or having more change in enthalpy as compared to the physical adsorption, and the reason is the intermolecular forces between these two type of the adsorption. Seventh one is the change in electrical properties of the adsorbent, and here again the first look at, there is no such changes, but in case of the chemical adsorption, it is showing the electrical conductivities, maybe the direct transfer of electron from the adsorbent to adsorbate or from adsorbate to adsorbent. And why there is no such type of changes in case of the physical adsorption? Again, Shabash? No? आप बताएं एग्जैक्टली. अब देखिए इलेक्ट्रॉन ट्रांसफर हो रहा है, इलेक्ट्रॉन ट्रांसफर कहाँ पे होंगे? एक ये जो इंटर चेंजेस बता रहे हैं, एड्सॉर्बेट से एड्सॉर्बेंट या एड्सॉर्बेंट से एड्सॉर्बेट, मतलब वही एग्जांपल पहले वाली आप ले लें. लेट्स सपोज दिस इज द इन केस ऑफ कार्बन डाइऑक्साइड, सही है. तो ये उसी वक्त होंगे जब अब आप कार्बन से ऑक्सीजन में आपके पास लेट्स सपोज जा रहे हैं, ऑक्सीजन से कार्बन में ट्रांसफर हो रहे हैं, ठीक है. तो ये उस वक्त होंगे जब दोनों में परमानेंट बॉन्ड है, सही है. जब होंगे तो जब बॉन्ड ही नहीं है तो हाउ द इलेक्ट्रॉन आर ट्रांसफर फ्रॉम adsorbate to adsorbent and vice versa. So because there are the strong bond or the chemical bond in case of the chemical adsorption, so this adsorption is showing the electrical conductivities. Electrical conductivities, just the flow of the electrons, or you can say if it is the electrolyte flow of the number of the ions. ठीक है. तो ये शो कर रहा है, no such changes are you can observe over here. It will remain the same. सही है, क्योंकि एक्टिवेटेड कार्बन है या आपके पास ऑक्सीजन है, जो उसकी पहले थी वही उसके बाद है, बिकॉज देयर इज नो स्ट्रॉन्ग बॉन्ड फॉर्मेशन बिटवीन द एड्सॉर्बेट एंड द एड्सॉर्बेंट. क्लियर है? दिस इज द रीजन. द एट्थ, दिस वी हैव आल्सो डिस्कस, बिकॉज इन केस ऑफ द फिजिकल adsorption, easily liquefiable gas absorb more as compared to the other one. So it depends on the what is the critical temperature. We have discussed in the previous class, and if you want to learn more, you can watch again that video. ठीक है. तो इसमें हमने critical temperature से उससे कोरिलेट किया था. जितना आपके पास ज़्यादा होगा उतनी ही उस पे adsorption भी जो है वो ज़्यादा होगी, because it is more liquefiable gas, more will be absorbed. But in case of the chemical adsorption, it is more specific as compared to the physical adsorption, क्योंकि उसमें chemical bond formation हुई, वो एक ही दफा होगा. It doesn't matter कि वो liquefiable है या नहीं. It will having a specific bonds between the adsorbate and the adsorbent. It will remain the constant. ठीक है. तो वो नहीं होगा. इसके अंदर क्योंकि मल्टी लेयर है, आपके पास adsorption है और absorb हो सकती है. सही. It depends on the nature of the gas. But in case of the chemical adsorption, there are the strong bond formation there, so there is no such behavior as we are considering in case of the chemical physical adsorption. Clear? Number 9th and 10th, pressure. Again, physical adsorption is directly proportional to the pressure, and the chemical adsorption there is no effect, and this we have discussed in detail. What is the reason? Shabash बताएं. शाबाश, और बताएं, आप बताओ आकाश, why the pressure is proportional to the absorption in case of the physical absorption. और शाबाश, आप बताएं। एक्चुअली बहुत सारे प्रोसेस है यहाँ पे आप डिस्कस कर सकते हैं, ये आपके पास लिचरेचर प्रिंसिपल भी है, एक्चुअली वही इसको फॉलो कर रहे हैं। लिचरेचर प्रिंसिपल वहीं भी आएगा जहाँ रिएक्शन जो है या प्रोसेस जो है वो रिवर्सिबल होगा। रिवर्सिबल प्रोसेस सिर्फ इन केस ऑफ द फिजिकल एब्जॉर्प्शन होगा, क्योंकि केमिकल एब्जॉर्प्शन में तो रिवर्सिबिलिटी है ही नहीं, ठीक है। तो जब आप प्रेशर का, इसका मतलब जो आपके पास इक्वल बीम है वो डिस्टर्ब हो रहा है सिर्फ फिजिकल एब्जॉर्प्शन ड्यू टू दी reversibility of the physical absorption, and Lechausseur principle is applying over here, and that's why that if you increase the pressure there would be a more absorption complexes form, so that's why the pressure is proportional to the in case of the physical absorption, and if you decrease that process then there should be a desorption or the process is going to be backward direction, but there is no, these phenomena are happening in case of the chemical absorption, that's why it is not having such effect as we have discussed in case of the chemical absorption. So ये reason जो है ये important है, क्योंकि I will ask that reason whenever you explain in the quiz or your mid or final. So just by writing this is not sufficient. The important thing is you have to describe the reason behind this, why this is proportional and there is the no side effect. The last one is the parameter is the localized or the non-localized. Localized means not moving. It is having a specific boundaries. Okay. So first let's look at the chemical absorption. So it is easy to compare. So adsorbed molecules are localized. Localized means with the strong chemical bonds, they are not moving. जहाँ पे fix हो गया वहाँ पे fix हो गया. सही है? So that's why chemical absorption process is called the localized. ठीक है? क्योंकि they have the fixed attachment with the adsorbate and the adsorbent. But in case of the physical absorption, we have the both process may happen, but the first one is opposite to the physical absorption. If the chemical absorption, comparison with the chemical absorption, if the chemical absorption is localized, then the physical absorption should be a non-localized, because there are not strong bond between the both adsorbate and the adsorbent, and the molecule may be moved from one pore to another pore depending on the application of the pressure. तो वो क्योंकि वो कहीं पे भी जा सकता है, लेकिन केमिकल बॉन्ड में ऐसा नहीं है. When there is the formation of chemical bond, you must need additional energy to break that bond. तो बॉन्ड ब्रेक भी हो जाएगा, लाजमी नहीं है कि वो उसी कंडीशन में वापस रहे. ठीक है. जब आपके पास हाइड्रोजन आपने उसमें गैस को आपने एटॉमिक फॉर्म में ऐड किया, मे बी नहीं आफ्टर रिमूवल ऑफ दैट बॉन्ड इट इज कन्वर्टेड इनटू हाइड्रोजन गैस, इट मे रिएक्ट विद some else elements to form another compound. लेकिन फिजिकल के अंदर जो है एब्जॉर्प्शन के अंदर ऐसी कोई बॉन्ड फॉर्मेशन, केमिकल बॉन्ड फॉर्मेशन, वीक बॉन्ड फॉर्मेशन है, तो दे हैव अ मूवेबल ऑन द सरफेस ऑफ द एडसोर्बेंट. दैट्स व्हाई दीस आर कॉल्ड द non-localized. That means they are free to move on the surface of the adsorbent. But in case they may be localized, it depends on the type of the forces. Let's suppose the hydrogen bond are stronger as compared to the other instantaneous dipoles forces. सही है. तो वहाँ भी आपके पास क्या है, for a certain time it may be localized because they are not moving, but with the application of the temperature, if you increase the temperature, they become a non-localized. ठीक है. Localized for a certain time, localized means they are not moving because let's suppose the hydrogen bond are strong or the dipole bond are the strong. So when you increase the temperature, there is the detachment between the adsorbate and the adsorbent, and further they can move, and now they are moving, that's why they are called the non-localized. So this parameter is dependent on the temperature. So physical adsorption may be non-localized or the localized. So these are the 10 different parameters on which you can differentiate between the physical adsorption and the chemical adsorption. Actually, these are the just maybe the comparison parameter, but these are the controlling factor to control the rate of the physical or the chemical adsorption. जो हमने last class के अंदर इसको डिटेल में डिस्कस किया कि ये इसको जो है वो कौन सी टर्म्स के ऊपर जो है physical or chemical adsorption को by using the rate of the adsorption we can differentiate. Of course, in general we cannot differentiate, but you can control the rate of the adsorption by using all these 10 parameters. मतलब कहीं पे कोई industrial process है, जहाँ पे manufacturing process है, या biological process है, application वही है जो start में हमने सारी discuss की. They are all valid and very important applications. Even from the biological system to the industrial system, everywhere adsorption process is happening. And the important of these parameters, to learn these parameters, now you can apply if you want to increase the rate of adsorption or decrease the rate of adsorption. If you want to increase the amount, to decrease the amount. So there are a lot of parameters you can use to control the rate of the adsorption. So purpose, objective of this learning is how can you control the rate of the adsorption by using all these 10 different parameters. So this is all about the comparison, and in the next we will study further